In this video, let's discuss about the classification of heat exchangers based on the relative direction of the fluid motion. There are mainly three types which can be classified as parallel flow, second one is counter flow, and cross flow. Let us start with the parallel flow heat exchanger. In this type of arrangement, the direction of hot and cold fluid are in the same direction. Consider this figure. Here, the red arrow mark shows the direction of hot fluid and the black arrow mark over here shows the direction of the cold fluid. In this figure, Tc1 is the temperature of cold fluid at the inlet and Tc2 is the temperature of cold fluid at the outlet. Whereas Th1 is the temperature of hot fluid at the inlet and Th2 is the temperature of hot fluid at the outlet. Below this figure, we can see the temperature profile of the heat exchanger, where the length of the heat exchanger moves to x-axis and temperature is on y-axis. Firstly, if we consider the temperature of hot fluid at the inlet, the temperature is at its peak, that is maximum, whereas the temperature of cold fluid is the minimum. As the fluid flows through the heat exchanger from initial to the final location, the temperature of hot fluid gets reduced, whereas the temperature of cold fluid increases. The arrow mark indicates the direction of fluid flow. Hence, in summary, for parallel flow heat exchanger, we can say that Tc1, that is temperature of cold fluid at the inlet, is minimum, whereas Th1, that is temperature of hot fluid at the inlet, is maximum. Hence, temperature difference between hot and cold fluid goes on decreasing from inlet to outlet. The second type of arrangement is counterflow arrangement. In this type of arrangement, the direction of fluid is opposite to each other. That is, if you look at the figure, the direction of hot fluid is from left to right, whereas the direction of cold fluid is from right to left. So if you consider the temperature profile graph, the inlet for hot fluid is in this position, whereas the inlet for cold fluid is in this position. The arrow mark indicates the direction of the fluid, where the hot fluid and cold fluid directions are opposite to each other. We can see from the figure that the temperature difference between the cold and hot fluid remains constant. To summarize with, again, the temperature of hot fluid is maximum, whereas the temperature of cold fluid is the minimum. If you compare the counterflow arrangement to the parallel flow arrangement, the rate of heat transfer in counterflow arrangement is higher compared to the parallel flow arrangement. The third type of heat exchanger is cross-flow heat exchanger. This type of heat exchangers can be further classified into two types. That is, first one fluid mixed and another unmixed, whereas second one, both the fluid are unmixed. So let us discuss about first one, that is, one fluid mixed and another fluid unmixed. In this type of heat exchangers, hot fluid flows in the separate tubes as you can see in the figure, whereas cold fluid is perfectly mixed as it flows through the heat exchanger from its initial to the final position. The temperature of this mixed fluid will be uniform across any section and will vary only in the direction of flow. Cooling unit of the refrigeration system is one of the examples for this type of heat exchanger. The second type of cross-flow heat exchanger is where both the fluids are unmixed. In this type of heat exchanger, fluid flows in a prescribed path and is unmixed as it flows through the heat exchanger. Hence, the temperature of the fluid leaving the heater section is not uniform. One of the examples for this is Automobile radiator